Lesson 2. Newton's First Law. Reading Guide. Key Concepts. Essential Questions. What is Newton's first law of motion? How is motion related to balanced and unbalanced forces? What effect does inertia have on the motion of an object? Vocabulary. Net force. Balanced forces. Unbalanced forces. Newton's first law of motion. Inertia. Inquiry. How does it balance? You probably would be uneasy standing under balanced rock near Buell, Idaho. Yet this unusual rock stays in place year after year. The rock has forces acting on it. Why doesn't it fall over? The forces acting on the rock combine, and the rock does not move. Identifying forces. Ospreys are birds of prey that live near bodies of water. Perhaps several minutes ago, the mother osprey in Figure 10 was in the air in a high-speed dive. It might have plunged toward a nearby lake after sighting a fish in the water. As it neared the water, it moved its legs forward to grab the fish with its talons. It then stretched out its wings and used them to climb high into the air. Before the osprey comes to rest on its nest, it will slow its speed and land softly on the nest's edge, near the young birds waiting for food. Forces helped the mother osprey change the speed and direction of its motion. Recall that a force is a push or a pull. Some of the forces were contact forces, such as air resistance. When soaring, the osprey spread its wings, increasing air resistance. In a dive, it held its wings close to its body, changing its shape, decreasing its surface area and air resistance. Gravity also pulled the osprey toward the ground. To understand the motion of an object, you need to identify the forces acting on it. In this lesson, you will read how forces change the motion of objects. Combining forces. The net force. Suppose you try to move a piece of heavy furniture, such as the dresser in Figure 11. If you push on the dresser by yourself, you have to push hard on the dresser to overcome the static friction and move it. If you ask a friend to push with you, you do not have to push as hard. When two or more forces act on an object, the forces combine. The combination of all the forces acting on an object is the net force. The way in which forces combine depends on the directions of the forces applied to an object. Combining forces in the same direction. When the forces applied to an object act in the same direction, the net force is the sum of the individual forces. In this case, the direction of the net force is the same as the direction of the individual forces. Because forces have direction, you have to specify a reference direction when you combine forces. In Figure 11, for example, you would probably choose to the right as the positive reference direction. Both forces then would be positive. The net force on the dresser is the sum of the two forces pushing in the same direction. One person pushes on the dresser with a force of 200 newtons to the right. The other person pushes with a force of 100 newtons to the right. The net force on the dresser is 200 newtons plus 100 newtons equals 300 newtons to the right. The force applied to the dresser is the same as if one person pushed on the dresser with a force of 300 newtons to the right. Reading check. How do you calculate the net force on an object if two forces are acting on it in the same direction? Combining forces in opposite directions. When forces act in opposite directions on an object, the net force is still the sum of the forces. Suppose you choose to the right, again as the reference direction in Figure 12. A force in that direction is positive, and a force in the opposite direction is negative. The net force is the sum of the positive and negative forces. The net force on the dresser is 100 newtons to the right. Balanced and unbalanced forces. When equal forces act on an object in opposite directions, as in Figure 13, the net force on the object is zero. The effect is the same as if there were no forces acting on the object. Forces acting on an object that combine and form a net force of zero are balanced forces. Balanced forces do not change the motion of an object. However, the net force on the dresser in Figure 12 is not zero. There is a net force to the right. Forces acting on an object that combine and form a net force that is not zero are unbalanced forces. Newton's first law of motion. Sir Isaac Newton studied how forces affect the motion of objects. He developed 3 rules known as Newton's laws of motion. According to Newton's first law of motion, if the net force on an object is zero, the motion of the object does not change. As a result, balanced forces and unbalanced forces have different results when they act on an object. Key concept check. What is Newton's first law of motion? Balanced forces and motion. According to Newton's first law of motion, balanced forces cause no change in an object's velocity, speed in a certain direction. This is true when an object is at rest or in motion. Look again at Figure 13. The dresser is at rest before the boys push on it. It remains at rest when they apply balanced forces. Similarly, because the forces in Figure 14, air resistance and gravity, are balanced, the parachutist moves downward at his terminal velocity. Terminal velocity is the constant velocity reached when air resistance equals the force of gravity acting on a falling object. Reading check. What happens to the velocity of a moving car if the forces on it are balanced? Unbalanced forces and motion. Newton's first law of motion only applies to balanced forces acting on an object. When unbalanced forces act on an object at rest, the object starts moving. When unbalanced forces act on an already moving object, the object's speed, direction of motion, or both change. You will read more about how unbalanced forces affect an object's motion in the next lesson. Key concept check. Inertia. According to Newton's first law, the motion of an object will not change if balanced forces act on it. The tendency of an object to resist a change in its motion is called inertia. Inertia explains the motion of the crash test dummy in Figure 15. Before the crash, the car and dummy moved with constant velocity. If no other force had acted on them, the car and dummy would have continued moving with constant velocity because of inertia. The impact with the barrier results in an unbalanced force on the car, and the car stops. The dummy continues moving forward because of its inertia. Key concept check. What effect does inertia have on the motion of an object? Why do objects stop moving? Think about how friction and inertia together affect an object's movement. A book sitting on a table, for example, stays in place because of inertia. When you push the book, the force you apply to the book is greater than static friction between the book and the table. The book moves in the direction of the greater force. If you stop pushing, friction stops the book. What would happen if there were no friction between the book and the table? Inertia would keep the book moving. According to Newton's first law, the book would continue to move at the same speed in the same direction as your push. On Earth, friction can be reduced, but not totally removed. For an object to start moving, a force greater than static friction must be applied to it. To keep the object in motion, a force at least as strong as friction must be applied continuously. Objects stop moving because friction or another force acts on them.